Really fast, guys. Well, I guess when we get to it, we'll get to it. When we get to it, we'll talk about the notes. So in the beginning, guys, all you're doing is transforming logs to exponentials and exponentials to logs. So that's very basic. Relax. Remember, because we said logs are exponentials. So log base b of a equals c. And sorry, maybe sometimes they just change the order. So what does this mean? If you want to go from that to an exponential, b to the power c equals a. See? B to the power c equals a. So there it is, log to exponential, exponential to log. All right, so question number one. Write the exponential equation as a logarithmic equation. All right, guys, so this is my base. And so I'm going to write log base 3 of square root of 27 equals 3 halves. And that's it. See? Cool or not cool? I just I just did this property up here, see? So 3 to the power 3 halves equals the argument. So 3 to the power 3 half equals the square root of 27. See, I just went backwards. So don't worry, I'm going to do it again and over. This is the base. So I'm going to write log base 6. Base 6 of what? Of 1 square root of 6 equals negative half. Hopefully we remember your laws of exponents, guys. That 6 to the negative half means that you can go 1 over 6 to the half. See? Don't worry. We'll talk about laws of exponents in a little bit. What's up, Vega?
Oh no, I was gonna ask, like, didn't the negative mean something special, but you answered it.
So 4 squared equals 16. Yeah, we know 4 squared equals 16, but they wanted to write it in logarithmic form. Log base 4 of 16 equals 2. La, 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 la. Okay, I'll stop. Y'all ready? Fabulous. There's a song that does that. I just can't remember what song it is. All right, log base 2 of 1/16 equals negative 4. That negative 4, by the way, guys, if you wanted to turn that into a positive exponent, that means the same as this, 1 over 2 to the 4th. And then 2 to the 4th is 16, right? 2 times 2 times 2 times 2. See, 2 times 2 is 4. 4 times 2 is 8. Bring that 8 down here. 8 times 2 is 16. See? And the 16 is in the bottom. Just something to keep a note on. Look at this one again. This is the base, so log base 6 of cube root of 36 equals 2/3. Yeah, that makes sense, because this 6 to the 2/3 means cube root of 6 squared. 6 squared is 36, see? And that's exactly what they have. Is this making sense, guys? L squared? What do you think? A little bit of loss? Okay. So check it out. All you're doing is this. So this now we're going backwards. So maybe I think you're gonna have an easier time with this. We're turning this. It says write the logarithm equation as an exponential equation. So we're just turning it into an exponential. 2 to the power negative 9 equals that. I'm just following this rule. 2 to the power negative 9 equals 1 over 5/12. That's all we're doing. Before we're going the other way around. So look at this. 7 to the power negative half equals 7 to the power negative half equals 1 over square root of 7. See? And side note, and we've already been mentioning this, but I'll mention it again. Side note. Remember when we did like x to the 5th over x cubed? You don't have to write this down, guys. Just listen. X times x times x times x times x. 1, 2, 3, 4, 5. Over 1, 2, 3. And then we cancel 3 of them. And then we said, oh, there's 2 of them there. So it's the same thing as saying x squared. So we did 5 minus 3. So that's the same thing. So if you have x to the power m over x to the power n, you can write this as x to the power m minus n. And by the way, if I were to have x squared over x to the 5th, this is 1 over x cubed. See, because there's 2 of them that cancel out. But look, 2 minus 5 is negative 3. You could have also said x is a negative 3. So how do I turn that positive one to a negative? By moving it up. See? So if I want to turn this to a positive, you bring it down. So that means 1 over 7 to the half. And then 7 to the half means square root. And OMG, look, that's 1 over square root of 7. See? So everything's connected, guys. All right. If you don't see a base, what base is it? 10. So 10 to the 2/3 equals the cube root of 100, which really is also 10 to the 2/3, right? And that's it. This one here, 2 to the power 8 equals 256. See? That's it. What do you think, L squared? Okay, check it out. 4 to the negative 3/2 equals 1/8. Right now, they just want me to write it as an exponential. They don't tell me to simplify anything. So there it is. What do you think? I have the song playing in my head, guys. It's been Kendric Lamar week, so in my head, the dun dun dun. It's not enough. Like it's just playing and repeat right now in my head. All right, this one here, same thing again. 7 to the power negative 3 equals 1 over 343. 7 to the power negative 3 equals 1 over 343. I guess that means, I guess it's that means. Remember, that means 1 over 7 cubed. So 7 cubed must be 343. And if I were to take my calculator and I go 7 to the 3rd power, look, 343. 7 times 7 times 7. Cool, right? All right. Let's see. What do we got? If you see something like this, hopefully your brain is automatically a 1. Because this is what it means. Put you know what? Let me just erase this question mark and equal it to x. So it's like saying this. It's like saying 9 to the power x equals 9. Well, the only value that will make that true is if x equals 1. Do you guys see that? So side notes, if you have log base b of b, automatically the answer is just going to be 1. Does that make sense, guys? All right, there you go. So if you can answer it right off the bat just by looking at it, just answer it. But if you can't, equal it to x and then just get a true statement. So turn it into an exponential because it's easier to see. 2 to the power x equals 16. And then just think like, okay, 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16. So x must equal 4. Do you see how we did that? Or is it not enough? It's not enough. See? 16. Dun, dun, dun. What's up? Give me an example. Oh, like
let's say instead of x power or 2 to the power x 16, like 2 to the power x is 18.
Oh. Well, that one's not perfect. I would use log rules, like ln both sides, ln. That x will come to the front. X ln 2 equals ln 18. And then to get x by itself, you would go ln 18 over ln 2. Notice that there's an ln on outside, so it's not ln of 18 over 2. It's just ln of 18 divided by ln of 2. But we're not there yet. We're actually going to cover that in the next round. Yeah, I don't want to confuse anyone, so I'm going to erase that. Cool, guys? All right, here we go. Equal that to x. If you see the answer already, then just answer it. 5 to the power x equals 625. Let's see, 5 to the power 1 is 5. 5 to the power 2 is 25. 5 to the power 3 is 25 times 20. 5 times 5, 25. 5 quarters, $1.25. 125 times 5. So, wait, did I say that? Yeah. So it's 4. Chop. I don't know what you did. I did this, guys. 5 in my head. I'm like 5 to the power 1 is 5. 5 to the power 2 is 25. 5 to the power 3, well, that's 25 times 5. So if I have 5 quarters, that's 125. And then 5 to the power 4, so 125 times 5. See? 125, so 5 to the power 4, 125, 125, 125, 125, 125. Did I do that right? That's 625, if I counted correct. I might have been one short. So 625. See? So cool or not cool? There is other ways, guys, in case you think like this is really hard. There's other ways. Let me show you the other way right now, but I just didn't want to talk about it right now because this is what we're going to do tomorrow. So let's say it wasn't perfect. You could bring that x down by using log rules. So we could have said ln, like whatever you do to one side, you do to the other. So if I put an ln there, I got to put an ln on the other one. And then look, that x comes to the front. And then you would have x ln 5 equals ln 625. And then, by the way, ln is just natural log. It's brothers with logs. We could have used logs as well. Divide by ln 5, both of them. And then you get ln 625 divided by ln 5. And then you could have just gone into your calculator here and you could have just done that and you get the same answer. Check it out. ln 625 divided by, what did I say, 5? ln 5. And voila. See? You could have also used log in case you're not entertained. You're like, I'm not entertained, Chav. All right, let's use log. Log 625 over log 5. Boom. Heck, you could even do the change of base formula. You could say math number, where's log base? Don't worry, we're going to talk about all this tomorrow. You could have done log base 5 of 625. It's not enough. Oh, yeah. Well, until that day. Cool, right? Look at all the different ways. It's not enough. I'll stop. All right, here we go. Log, what is the value? So equal this to x. If you don't see it immediately, 8 to the power x equals 512. And then just go down the number line. You have a calculator. So it's not, 8 to the power 1 is 8. 8 to the power 2 is 64. 8 to the power 3, let's see. 8 to the power 3. 512. Is that what they wanted? So there it is. So what does x equal? 3. See? This one here, equal it to x. If you don't see it right off the bat, turn it into an exponential. It's easier. And I think in algebra 2, you probably did this. You probably made the bases the same. So you probably were like 3 to the power x equals, and then I know this is 9 times 9, but 9 breaks down to 3 times 3. And so see, how many 3's do you see? 4. So 3 to the power x equals 3 to the power 4. If the bases are the same, then obviously x must equal 4. Do you guys see how we're doing it, guys? So there's so many ways to do it, guys. So this one, equal that to x. 2 to the power x equals the 4th root of 8. Chop, how are you going to do this one? Like this. I'm going to turn that 8 into 2 to the power 3. And then we're going to do the radical thing, turning the radical into an exponent. See? So remember yesterday or 2 days ago, we said the nth root of x to the power n is the same thing as x to the n over m. You guys remember that? Okay, so once you remember that, that's what we're going to do. 2 to the power x equals 2 to the power 3 over 4. The bases are the same, so that means x has to equal 3/4. Do you see how we did that, guys? Vega, we saw how we did that? Okay. Are you sure?
Yeah.
Okay. And then we go back to this here and equal that to x. 2 to the power x equals 32. You could just go down the line, or you can make this into 2 to the power x equals 2. 2 times 2, 4. 4 times 2, 8. 8 times 2, 16. 6 times 2, 32. I think I said 5th. So there it is. So this value is 5. That equals 5. So 3 to what power will give you 1/9? Let's see. Can you do it without writing anything? Just the answer? It's a negative number. What is 9? 3 squared, right? And it's in the bottom, negative 2. See? If you don't see it, it's like, Chav, I don't see it. Okay, look, just do this. Equal that to x and go 3 to the power x equals 1/9. See? And then you can turn that 9th into 3 squared. 3 to the power x equals 1 over 3 squared. And then bring this up. 3 to the power x equals 3 to the negative 2. Well, the only way they're going to be the same is if x equals negative 2. Cool, right, guys? All right. Have you guys talked about natural log? Do you guys remember about it? No? Okay. We'll give you this for now. We'll talk about it next time we see each other for full details. Go side note and write ln of e equals 1. E and ln are inverses of each other. E is just a number like pi. So y equals e to the x and y equals ln of x are inverses of each other. Are inverses of each other. So because of that, ln of e is just 1. Okay. Let's do it. Turn this into an exponential. Ln of e to the 1/3. Turn the radical into an exponential. You could also, you know what? I'll give you another side note. Yeah, I'll go ahead and log base e of x is ln of x. That's another side note. We'll talk about it. Don't worry. I'm going to use the power rule. Bring the 1/3 to the front. 1/3 ln of e. And we just told you that ln of e is 1. So if ln of e is 1, that means this is just going to be 1/3. Dun, dun, dun. It's not enough. What do I do with this? Bring the e to the 4 up. So that's ln of e to the -4. And then just use the power rule. Bring that -4 to the front. -4 ln of e. And there it is, guys. How are we feeling? We feeling okay? Check it out. It doesn't have a base in the bottom, so that means this is base 10. Log base 10. Yeah, that was weird. I'm not going to do that again. 10 to the 1/3. So bring that 1/3 to the front. 1/3 log base 10 of 10. And then hopefully you remember that we just had a side note. Whenever you have log base b of b, that's just 1. So what's 1 times 1/3? 1/3. You could always turn them into an exponential if you want, if you think that's easier. Look, let me write it in a different color so we don't get confused. You could always say that equals x, 10 to the x equals 10, the cube root of 10, and then turn that into an exponential. 10 to the x equals 10 to the 1/3. Oh, look, there it is. The only way that these are going to be the same is if x equals 1/3. So there's so many ways to do it, see? There's so many ways to do it. Again, this one right here. Let's see, 32, if I say that equals x, 32 to the x equals 1/4. I'm going to turn that 32 into 2. 2 to the power 5 is 32. 2 times 2 is 4, 4 times 2 is 8, 8 times 2 is 16, 16 times 2 is 32. Do you guys see that? So I'll show you details here. 2 to the power 5 raised to the x equals 1 over 2 squared. Now remember, an exponent raised to an exponent, you can set them equal to each other. You just multiply them. What did I say? An exponent equals an exponent raised to an exponent. Multiply them. That's 2 to the 5x. And then set them equal to each other. I think I was trying to talk too fast. 2 to the -2. So now the only way these are going to be the same, guys, is that 5x equals -2. 5x equals -2. X equals -2/5. And there it is. I know, guys, you have calculators. Do these without a calculator. But look, I'll show you. Here's the calculator. See how that's called the base? And I know you could just do this with a calculator. You could just go math and then look for something called log base. It's down here. There it is. And you can literally just type it in verbatim, 32 and 1/4. And you can just go 32, and you can just go over here and put alpha y equals, you don't have to put the fraction, you can just type 1 divided by 4. And you'll get your answer. Turn it into a fraction. Look. See? But don't do that, guys. Don't defeat sweat. Understand the little nuances, the little intricacies, because you're not always going to have a calculator. There's a lot of exams that are going to be no calculator based, and the log exam that might be the case for a little bit, for at least half the test, for something like this. You know what I mean? So don't worry, we're not going to give you numbers that you can't figure out. All right, we're almost done. Last page, and then we'll set you guys loose. We'll stop. All right, same deal with this. It says evaluate, so equal it to x. And we're gonna go. Let's see if you can do it without doing anything. Do it on the side here. 32 to the power x equals 1 over 16. I know that 2 to the power 5 is 32. So 2 to the power 5x, because the x is there, right? 2 to the power equals, and I know that 16 is 2 to the power 4. If I bring it up, 2 to the power negative 4. Does everyone see how I got that? I guess I'll make a side note. 1 over 2 to the 4 equals 1 over 16. And then I brought that up, so it turned it into a negative exponent. The only way those are the same, see the base of 2, is if 5x equals negative 4. So x equals negative 4/5. I know, it's not exciting. It's not like, wow. Equal this to x. I'll put it in a different color so it won't overlap with the one on the top. A to the power x equals 128. I know that 2 to the power 3 is 8, so this is going to be 2 to the power 3x, an exponent raised to an exponent, equals, what about this one? 2 to the power, I always have to do this, 2 times 2, 4, 4 times 2, 8, 8 times 2, 16, 16 times 2, 32, 32 times 2, 64, 64 times 2, 128, 7. See? So there it is. So 3x equals 7. So x equals 7/3. You can check it by typing that into the calculator and it'll give you an answer. It'll give you that answer. Look, I'll show you. Math. And I already forgot what number it is. Log base, letter A. And what was my base? 8 and 128, right? And then just turn it into a fraction. Math, fraction, enter. See? 7/3. But don't just use the calculator to check, guys. Don't do it for, all right, equals x. Oh, I'll do it in red here. We're almost done, guys. We're almost done. 8 to the power x equals 16. So this 2 to the power 3x equals 2 to the power 4. So 3x equals 4. So x equals 4/3. Let's see. Can you think we can do this without writing anything? Let's see. 32 is 2 to the power 5. So I see a 5, and then 16 is 2 to the power 4. So I see 4/5. See? I did it without even writing anything. But relax, you don't have to write something. Look, 32 to the power x equals 16. So that's 2 to the power 5x equals 2 to the power 4. See? 5x equals 4. X equals 4/5, which is what we got. Boom. Okay. This one's going to be simple because now check it out. X to the power 2 equals 9. So this is x squared equals 9. There's only one number that fits. 3. That's the only number. 3. So there it is. That's it. X equals 3. Okay. Let's go to the top right. 2 to the power x equals 128. 2 to the power x equals 2 to the power 7. So x equals 7. 2 to the power 7 equals 128. Do you see how we're doing it, guys? Okay, these are the simple ones. Whenever it's like this is going to be just 4 to the power 3 equals x. 4 to the power 3 equals x. And then just expand it. 4 times 4 is 8. 16, sorry. 16 times 4 is 16, 32, 64. So 64 is your answer. Sorry, brain fart. 3 to the power x equals 81. Well, 3 to the power 1 is 3. 3 to the power 2 is 9. 3 to the power 3 is 27. 3 to the power 4. X equals 4. And I'll show you because that is 3 to the power 4. 9 times 9 is 81. 2 more, and then we're done, and we'll set you loose, and we're done, guys. 6 to the power 3 equals x. Oh, so those are the easy ones. 6 times 6 is 36. 36 times 6, 200, 216, 216. Last one. You ready, Hernandez? Or is it not enough? Oh, okay. X to the power 5 equals 32. Help me out, miss. One number. Yeah, it's 2. It's 2. 2 times 2 is 4. 4 times 2 is 8. 8 times 2 is 16. 16 times 2 is 32. There it is. What you guys think? Not enough? Is it not enough? Oh, okay, it's enough. Bless you. Bless you squared. Oh, no. Yeah. And then, oh, I know. For the future, that's for the future. Oh, the record is like 14, I think. Malena Flores last year. She just went choo 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 choo, and she did it like, or maybe it was 16 times, but yeah, it was. Oh, it was recorded somewhere, because she did it when we were live, and we have it recorded somewhere. So I'll look it up. All right, guys, that's it. Log into Delta. If you need to take a little break, take a little break, but log into Delta and take care of it, and we're done.